Thank you very much for this very generous introduction. It's really a pleasure to be here, and also I have to congratulate all the other presenters. It's really been a very enjoyable conference so far, and I'm really looking forward to this second day of the conference too. I think that being a demographer is really a privilege because it's a job that is enormously satisfying. It gives you a lot of enjoyment, autonomy, but it's also really a privilege because we have, wonderful colleagues and teachers like Alexia. So I also want to acknowledge that, this is really a wonderful community to be a part of, and I really look forward to learning and engaging with all of you today and also in the coming years. So the title of my talk today is The Digital Revolution and Demography, Perspectives from Digital and Computational Demography. And what I'm going to do in this talk for the next 30 minutes is to sort of outline what I see as digital and computational demography, which is demography in relation to the digital revolution and what that really means. And then I'm going to give examples from a research project that I've been conducting together with many colleagues, which is on the digital gender gap, or the Digital Gender Gaps Project. And this project has had multiple funders over the years, and currently the most prominent funder is the Bill and Melinda Gates Foundation. So I'm going to present work from this project, which I think exemplifies both the questions as well as the approaches of digital and computational demography. So to start off with, really the premise for my talk today is this, the digital revolution, and this is the slide, the graph on the slide that you see, which is this rapid proliferation of internet and mobile technologies that has really happened, if you think about it, in the last 25 years. So this is a very short span of time that we've seen very significant technological transformation. This is here in red, mobile phones, and then in the black, you see mobile internet. You see also in gray, fixed internet. And what you see in the blue, plateauing, is landlines. And this is a global picture. But if we look at the next slide, we see here that this is really a trend that affects all regions of the world. It is no region of the world is unaffected. Across Africa, Asia, Europe, the Middle East, North and South America, and Oceania, we see a similar pattern of diffusion of mobile and internet technologies. And in fact, if you look particularly at Africa and Asia, we actually see very little blue in this graph. We see a lot of red, and we see black and gray. And this really means that if we think about large-scale telecommunication connectivity, mobile and mobile internet have really been the first large-scale telecommunication infrastructure that have enabled connectivity in a scale that has not been the case before. And that, I think, is a really important and salient point that will be an underlying theme in a lot of my talk, because it has implications for demography as a discipline, but it also has implications, of course, for society at large. All of us at the moment in our pockets are holding a mobile phone. We have people who are joining remotely from many parts of the world in this room, even though they're not here. And of course, this means that digital technologies have changed the way we access information, how we communicate with each other, how we interact with each other, and how we access vital goods and services that are relevant for our life and our life course domains. This is also, I think, probably most rapidly or most sort of saliently seen in the context of the COVID-19 pandemic, where, of course, technologies were essential not just for accessing things, but also doing really important things like for children going to school. So this digital revolution, which has been, as I said, a rapid transformation in the last roughly 2 decades, is first and foremost a social transformation. And I think from a demographic perspective, this is really important for us to take notice of and ask how and for whom are these processes of digitalization and the diffusion of digital technologies, the availability of digital information and capabilities, which can take many varied forms, affecting demographic behaviors and outcomes. And I think that is a really fundamental question that demographers really should be asking. But also we're in a conference about inequalities, population inequalities, about heterogeneities, and I think this is a question also that demographers and social scientists at large should be asking is, how are these technological diffusion processes reshaping inequalities in populations? Now, if we look at the Global Sustainable Development Goals, arguably one of the most prominent roadmaps for global development across the world, the SDGs actually talk a lot about technologies at multiple parts in the SDGs. So SDG 5, which is on gender equality, says technology should potentially empower marginalized populations, and SDG 5 specifically pledges to enhance the use of information and communication technologies to promote the empowerment of women. So here is a vision of technologies potentially being able to empower marginalized groups through promoting cost-efficient access to resources, promoting service seeking, and enabling other forms of connectivity that arguably can improve outcomes. But the question to me is ultimately an empirical question. There's a theoretical potential, and I would argue that many of technology's effects can also be theoretically ambiguous. They can go in different directions. And I think Anna's talk yesterday very nicely showed how there can be plausibly, empirically, very differential effects across different groups or different kinds of mechanisms through which ICTs might act. So ultimately, to me, this is an empirical question, and a question that, again, the demography community should be asking more broadly. So I first came to this question as an interesting substantive empirical question about trying to understand the social and demographic implications of digitalization and digital technologies. But very soon after I started this, or I was intrigued by this question, I realized that there's a data gap. There are actually very few large-scale, nationally representative data infrastructures, the kinds that demographers like to use, that have both digital questions and social and demographic questions in them. And this data gap is especially amplified in low and middle income countries. So here you see a map where I've tried to compute a simple indicator, a female-to-male ratio of internet use, using a relatively recent survey that is, again, a good survey that's nationally representative. And for this indicator, there are many countries in sub-Saharan Africa, and here also in South Asia, where we actually can't, using a recent survey, compute this indicator, right? And this is, for me, an interesting data gap where there is a really important social process that is unfolding, technological diffusion, but we actually don't always have the traditional tools to be able to analyze these processes as they're unfolding. Which brings me to the fact that the digital revolution, of course, has also been a data revolution of a type, because the very use of web, social media, and mobile phones generates new data streams. The fact that we use these technologies generates new data streams that have the potential to provide novel measures more broadly about societies, but also, if we're interested in studying digitalizing societies, specifically about digital behaviors and digital adoption processes. And this is what I see as the core agenda of digital and computational demography. And this is what I, together with colleagues, both in Oxford as well as at the Max Planck Institute for Demographic Research, have tried to sketch out as the agenda for digital and computational demography as advancing the understanding of both the data, the methodological, but also the social implications of the digital revolution. And that's where I think demographers have a core task in advancing both these lines of inquiry. So now in my talk, what I'm going to do is provide some examples of ongoing research that I've done together with colleagues, where we've asked questions about both the sort of social as well as explored the data implications of the digital revolution. And we're going to do this through the lens of this project, which is the Digital Gender Gaps project, where we're specifically asking questions about how does the proliferation of digital information and capabilities affect sustainable development goals, particularly in relation to SDG 5 on gender equality. And then I'll also, as I said, in the latter part, talk about new kinds of data streams, particularly from social media, and how they might also help us explore some of these domains. So the idea that technologies, broadly speaking, or mass media can have impact on demographic processes, particularly in the fertility literature, is not a new one. Both within the demographic literature as well as broadly the development and economics literature, this idea that there's exposure to new information, new behaviors, which can also result in a shift in attitude surrounding, for example, ideal family size, is something that has been shown, for example, in relation to the TV. Right? So this is not a new idea of sort of media affecting demographic behaviors. If we also look at sort of diffusion theories of fertility decline, the idea that technologies can alter paths for social learning and social interaction, right, is also a very core idea in a lot of these ways in which we think about fertility transitions. Now, if we think about mobile phones, but also the internet as a technology more broadly, we can think about multiple mechanisms through which they might plausibly affect different types of demographic outcomes linked to health, well-being, linked to sexual and reproductive health, also linked to the formation of intentions surrounding family, migration, and so on. So one potential mechanism is that they can, of course, improve access. Technologies can improve access to private information. I emphasize private here because that's a contrast to sort of a more public medium, unidirectional medium like the TV, as well as provide access to services such as through mobile money, m-health. Particularly here, I'm thinking also about very basic phones like feature phones being able to provide these services. Mobile phones and internet technologies can, of course, enable connectivity and access to networks. And again, the diffusion of new ideas, paths for social learning through social interaction, of course, are enabled by the connectivity afforded by technologies. There's also exposure to the life of others, and particularly, in some cases, more globalized media content. And again, I want to take a step back here to emphasize that some of these mechanisms can go in very different directions, right? Being better socially connected doesn't always necessarily mean that better social connections lead to positive outcomes. It can also lead to socially regressive outcomes in some cases, just because they allow for viral diffusion processes to happen quicker. Right? So many of these effects can also be theoretically ambiguous, which is why I think it's really important that we study these things in empirical as well as in context-specific ways. So we started exploring this question of the impact of mobile phones together with colleagues at Bocconi University, looking at how mobile phones were linked to sustainable development outcomes, first at a very broad macro perspective by building a country panel data set where we had countries observed from the 1990s till about 2017. And we wanted to just look first at the macro level and how the expansion of mobile phones was associated with outcomes such as the UNDP's Gender Inequality Index, the contraceptive prevalence measure, also looking at under 5 mortality, and just looking broadly in a country panel analysis where essentially our key predictor was mobile phone access or technology subscriptions per capita, and looking at outcomes such as Gender Inequality Index, contraceptive prevalence, and the mortality outcomes, we essentially found that through a range of different specifications that we tried and controlling for things like educational expansion, population density, urbanization, we always found that the mobile phone variable remained, despite these controls, always statistically significant. And the strongest associations between the mobile phone variable and these outcomes was always in countries in Q1, Q2 of GDP per capita, which is countries that are essentially low and lower middle income countries, where we saw the sort of most powerful associations at the macro level between mobile phone diffusion and these outcomes. Then we decided to go to the micro level using individual level data from the demographic and health surveys, which, starting phase 7 of the DHS program, incorporated questions about mobile connectivity, so mobile adoption, mobile ownership, and also internet use. So this is starting phase 7, roughly around 2015-16 onwards. We see these questions emerging or being included in the DHS. So these were the first 7 countries for which phase 7 data with the mobile phone variable was available. These are countries across sub-Saharan Africa. And we see different levels of mobile ownership in the women's module of the DHS on this slide. So we have very low levels of mobile adoption here in Burundi and considerably higher levels of mobile adoption in Zimbabwe. But when women do own mobile phones, as this graph shows, they also do use it for things like financial transactions. So the red bar here shows the fraction of women reporting that they're using their mobile phones for financial transactions among those that own mobile phones. We also see some evidence here for receiving family planning messages on their mobile phones. Now, of course, the DHS, as some of you will know, is a cross-sectional survey. So a big challenge, of course, is that if we want to study the link between women's empowerment or sexual and reproductive health and mobile connectivity or mobile ownership, there's an endogeneity problem, right? The more empowered women might be the ones who are actually owning the mobile phones. So to address this endogeneity, we connected or linked the DHS with a measure of lightning strikes observed from space. So why do we care about lightning strikes? Well, the telecommunications engineers have told us that places where there is high lightning strike intensity are places where also mobile towers break down. Where mobile towers break down, of course, connectivity is poorer, which is something that gives us plausibly exogenous variation in the first stage of a two-stage least squares, two-stage IVSLS approach, where we have lightning strikes is the instrument that allows us to essentially gives us a quasi-experiment to study the impact of mobile adoption on the outcomes of interest. So essentially, we're using lightning strikes as a quasi-experiment to study the impacts of mobile adoption on a range of women's empowerment and sexual and reproductive health outcomes that we have in the DHS. And using this IV, so first we just do probit or OLS models where we look at individual level effects of mobile ownership among women on outcomes such as deciding on contraception, equality in decision-making within the household, surrounding their health, large purchases, their children's health, the use of modern contraception, and knowledge around HIV testing. So when we look at this range of sexual and reproductive health behaviors and the Women's Empowerment Linear Index in the DHS, we see associations between the mobile variable and these other outcomes. And for most of these, we also see that these associations are robust also to the use of the lightning strikes IV. In terms of the size of these effects, when we compare the coefficient, we see that it's roughly the same as about the size of the urban variable across all of our models. And when we explore and think about this a bit more, we actually see that when we do, again, a sort of analysis of who is this payoff of mobile connectivity really meaningful for, we find that it's actually the areas with the lowest levels of local development. This is on the x-axis, and this is using a variable of night lights for measuring local development at the level of DHS clusters. We find that it's actually the areas with the lowest levels of local development that have the highest payoffs of mobile connectivity. So the way we interpret this is that in areas where other forms of infrastructure are lacking, mobile is filling a gap and is providing and enabling access to key services and key knowledge diffusion behaviors that otherwise are unavailable. In a separate analysis using the Afrobarometer, looking at Middle East and North Africa, and that region in particular, sorry, the Arab barometer, not the Afrobarometer, we find similar sort of differential effects by gender when we look at an outcome which is the willingness to emigrate. So we're looking at migration intentions in this paper and also looking at internet connectivity more specifically and looking at sort of the differential impacts of internet connectivity for willingness for migration intention formation. And we see here as well that in the blue bars, internet use is associated. And here also, we try and account for endogeneity using a propensity score matching approach, and we find that women who are using the internet have a stronger propensity or a willingness to emigrate, and we see this kind of marginal payoff of internet connectivity seems to be larger for women, the marginal payoff, than for men. And we see a similar effect operating also when we also look by education. So amongst those who have lower levels of education, again, the marginal payoff of internet use and internet connectivity seems to be larger than amongst those who are higher educated. So just to summarize these social impacts, what this analysis is showing us is that mobile phone ownership and internet adoption is linked to key SDG-relevant outcomes on women's empowerment, reproductive and sexual rights, and these broader antenatal health outcomes. And we see these bigger payoffs at lower levels of economic development, which of course tells us that it's important to track digital connectivity more broadly by gender. But I want to come back to this point that I made at the beginning, which was we still have this data gap where, while it is increasing, we still have not that many surveys, or at least traditional data sources, where we have this measure of digital measures as well as social and demographic measures. So here, as I said, the digital revolution is also a data revolution, and how can this potentially help us fill some of these data gaps? And here, one line of research that we've been pursuing has been using this form of social media data, which is social media ad audience estimates, which is essentially repurposing a data stream that is provided to advertisers or potential advertisers on social media. All social media companies have targeted advertising as a core part of their business model, and they all provide estimates of audiences, how many users of X characteristics, gender, location, age, etc., are on a given platform. And here, for example, on the screen, you can see an example where I've queried this for Nigeria, women aged 18 plus, how many users are there, and we have 12.2 to 14.3 million. All platforms provide this. This is what the audience estimates platform looks like for LinkedIn. And you can see here that you can query different types of platform-specific characteristics on LinkedIn, but you can ask more about professional histories, industries, and so on. And we've done this through also looking at other social media platforms, including, which may be region-specific ones, for example, like Weibo for China. And some of the applications, at least in the gender gaps line of work, is we've been trying to use these social media marketing streams to predict SDG 5 relevant indicators, such as the internet and mobile access gender gaps. And you can see examples of this on our website, digitalgendergaps.org, where we particularly use social media marketing API data from Facebook, but we've also explored Google AdWords, for example. Professional gender gaps, and looking also at different types of professional gender gaps, and also ask questions about the different types of social networks that men and women have on professional platforms like LinkedIn, as well as the impacts of online networking on job mobility outcomes like getting a promotion or getting a relocation. Looking at these kinds of job mobility outcomes also linked to the use of platforms, we've also tried to do using these types of data streams. But as I said, a lot of the core part of what we've tried to do first is to try and sort of just capture these data, collect these data to expand geographical coverage and provide more timely predictions on social indicators like these different types of gender gaps, and also to see to what extent they can help us monitor rapidly evolving situations. I should say that, of course, a big limitation with these data are that these are data that are being repurposed for social research. They are not meant for research originally, like a survey is. So we have very little control as researchers. We don't have access to past data. We have data access constraints. They're also being generated essentially through black box algorithms where we don't always know or fully understand the data generating process behind these data. But one important, as I said, part of this line of work for us has been to try and use these data to try and fill internet and mobile access gender gap indicators or data gaps on this indicator. And the key approach here is that we've been using the Facebook gender gap to predict the internet gender gap, where we are trying to use this key Facebook variable, which is defined here as the female-to-male ratio of Facebook users, divided by the female-to-male ratio of the population, for example, in a given country, and we're using that to predict this other indicator, which is the internet gender gap, where we get the internet gender gap from whatever surveys have this available for. And we find often that this Facebook gender gap, when we compare this compared to a lot of other variables in our data set, is actually the most strongly correlated with the internet gender gap. And this remains the case, even though we've been monitoring this over a long period of time now for 6 years. And we find that it's stronger than any other development indicator. And our modeling approach, so essentially we're trying to build a predictive model where this is one variable of many possible variables, where we try only using online or social media variables. That's our online model. Then we try a model where we use social media variables together with other development variables, such as, for example, the GDP per capita or the Human Development Index. And then we try a baseline model saying, what if we didn't have any social media data? How would we perform? And then that's our sort of offline benchmark model that we're always trying to beat with these other models. And this is what, using the Facebook gender gap to predict the internet gender gap, this is what this map looks like. So this is a predicted internet gender gap using the Facebook gender gap. And we can increase geographical coverage of this indicator in places where we didn't have this data available through the survey because of, again, the high predictive performance or the strong predictive performance of the Facebook-generated gender gap variables. And when we look at this map substantively, it tells us that in many regions of sub-Saharan Africa, but not in southern Africa, and also in South Asia, we have large gender gaps in internet and mobile connectivity. Women are much less likely, to a fraction of about 30 to 40%, much less likely to be online, and they're also much less likely to own mobile phones in these country contexts. What we're working on now in the project is we're trying to make these maps subnational. And we're trying to here, on the left-hand side of the graph, you see this is data on, this is on the gender gap in mobile ownership from the DHS. And then on the right side of the panel this is the predicted values of this using the Facebook gender gap again. To give you an example of how these kinds of data streams can be useful for tracking rapidly evolving situations, here's an example during the fall of Kabul in Afghanistan. So in the summer of 2021, we saw the Taliban recapture of Kabul, and we see here around this time in Afghanistan, our data stream, the social media data that we're collecting every day on Facebook. Here we have daily active use of Facebook, and we have in the green line the female-to-male ratio in Afghanistan. So if we see, on average, women and girls are much less likely to be using social media in Afghanistan, but around the time of the fall of Kabul, which is around C and D of in this graph, we see rapid increases in daily active use, particularly amongst adolescent girls in Afghanistan. And this really appears to be the cohort of girls that had previously in their life never experienced the Taliban rule, right? So we interpret this as a form of online protest that we are able to measure in real time as it's happening around a rapidly evolving socio-political situation. And we see over this short period of time, girls become a bigger share of teenage Facebook users, although then by the end of the year, we actually see the levels start to fall again. So the last example I want to give for the other kinds of uses of these kinds of data could also be that, of course, as I've tried to make the point, it's important for us to know about gender gaps in digital connectivity and track them in of themselves as an interesting dimension of population inequality. They can also be helpful for illuminating biases as we do more and more analyses using different types of digital platforms and online populations. So here's an example where we tried to use data from the LinkedIn marketing platform, and we were trying to use the LinkedIn gender gap to predict the ILO professional and managerial gender gaps. So ILO data, which use labor force surveys, we were trying to sort of compare how does LinkedIn gender gap compare to the ILO gender gap and try and predict that. But one interesting bias we found when we tried to analyze the residuals of our predictions was that in countries where women are less likely to be online, they are less likely to be internet users, we actually found that LinkedIn gender gaps were often over-predicting professional gender equality. So we actually had this sort of upward bias in our model prediction in these countries where there's high levels of a digital gender gap. So it's useful for analyzing these patterns of bias, in addition to, of course, the other kinds of just general prediction applications. It can also, the digital gender gap is also very useful for us to thinking about issues of selectivity and bias in uses of online data sources. So just to summarize, what I've tried to emphasize in my talk today is that the digital revolution has both social as well as data implications, and that is what I see as the kind of core agenda of digital and computational demography. From a broader sort of sustainable development analysis perspective, I think understanding differential impacts of digitalization is really key for understanding broader demographic as well as sustainable development dynamics. But to ask these questions, we need to harness both traditional sources of data, but also think about new sources of data that the very use of digital technologies is generating within a broader diversifying data ecosystem. Demographic analyses of digital populations is interesting because, of course, at one level, it's important for us to understand bias and generalizability, which are core questions that demographers are interested in. But I also think that we need to be thinking about digital inequalities more broadly from a demographic perspective as a new dimension of population inequality that is important for us. And there is now a bigger discussion within our universities and across the social sciences of this computational turn in the social sciences. And I think demographers should really be a core part of that discussion. We should really be vital actors. We should be making our voices heard in this broader discussion, because one of the really powerful things about demography as a discipline is that it has a very global vision as a discipline, right? And I see that also in this conference. We have papers that reflect really many parts of the world, and having that global vision as a discipline is also really powerful for us, also for making computational social science global, but also because we are a discipline that's cared about things like measurement, bias, generalizability, we can bring those trends also to the bigger and broader discussion about computational social science. So that's all I have to say. Thank you very much, and I look forward to the Q&A.